Hello everyone, today we're diving into midpoints and the Cartesian plane. And hey, here's a joke to get started. Why did the geometry book look so sad? Because it had too many problems, haha! Alright, no worries, we'll tackle these together. And if you need a second to think things through, feel free to pause. Ready? Let's go. On this first slide, we're setting up on the Cartesian plane. Now, this plane is a helpful grid that lets us locate points using their horizontal or x values and vertical or y values. We'll be using this coordinate system to locate the vertices of our triangle and then calculate the midpoints along each side. Let's take a closer look at this triangle on the next slide. Now, on the second slide, we're getting familiar with the triangle's three vertices. 1, 0, 0, which is right at the origin of the plane. 2, 30, 70, which is up high on the grid, and 3, 54, 0, which lies along the x-axis. So with these 3 points, we've got our triangle, and our task is to find the midpoints along each side. We'll be calling these midpoints points P, Q, and R. Let's head to the next slide. On this slide, you can see our objective. Find the coordinates of points P, Q, and R, which are the midpoints of the triangle's sides. We'll do this using something called the midpoint formula. It's quick, simple, and helps us find the point exactly halfway between two given points. Ready to see what this looks like? Let's check out the next slide. Here's the midpoint formula. The midpoint between 2 points is found by averaging their x values and their y values separately. We add the 2 x values together, divide by 2, then do the same for the y values. This gives us the exact point right in the middle of the 2. We'll apply this 3 times, once for each side of the triangle. Let's get started with our first midpoint, point P. Here we are, finding point P, the midpoint of the line connecting 0, 0 and 30, 70. Let's break it down. For the x-coordinate of point P, we add 0 and 30, which gives 30, then divide by 2, giving us 15. For the y-coordinate of point P, we add 0 and 70, giving 70, then divide by 2, giving us 35. So point P is at 15, 35. This point divides the line between 0, 0 and 30, 70 right in half. Let's head to the next slide to look at point Q. Next up is point Q, the midpoint of the line connecting 0, 0 and 54, 0. Since these points lie on the x-axis, this one's straightforward. For the x-coordinate of point Q, we add 0 and 54, which gives 54, then divide by 2, giving us 27. Since both y-coordinates are 0, adding 0 and dividing by 2 still gives 0. So point Q is located at 27, 0. Because it lies on the x-axis, the y-coordinate is 0, which is a neat feature of the Cartesian plane. Ready to find our last midpoint, point R. Let's go to the next slide. Now let's find point R, which is between the points 30, 70 and 54, 0. For the x-coordinate of point R, we add 30 and 54, which gives 84, then divide by 2, which gives us 42. For the y-coordinate of point R, we add 70 and 0, giving 70, then divide by 2, giving 35. So point R is at 42, 35. Perfect, we've now calculated the midpoint of each side of our triangle. Let's summarize these results on the next slide. To wrap up, here are the midpoints we found. Point P is located at 15, 35. Point Q is located at 27, 0. And point R is located at 42, 35. By using the midpoint formula, we've located each of these points on the Cartesian plane, deepening our understanding of how coordinates work within a shape. Thanks so much for following along. If you enjoyed this journey into the Cartesian plane and midpoint calculations, please like, subscribe, and join us again for more geometry fun. See you next time.